f of x, which is x squared minus 8 for x less than negative 2, and negative x squared plus c for x greater than negative 2. And we're asked to find the value of c. This is called a parameter. The name is not important. I'm going to test you on that, but just remember. So, such that the limit of f of x as x approaches negative 2 from either side exists, which means is a number. Very good. So this is the problem. You can download it if you'd like, but I already copied it here. Okay. So when we are told that, when I'm told that the limit from either side of negative 2 exists, I'm automatically told that the limit from the left and the limit from the right, they both exist and they are equal to each other. So for this to happen, the limit from the left must exist, the limit from the right must exist, and they must be equal to each other. The function may or may not be defined here, we don't care. As long as this limit and this limit exist, they both exist and they're equal to each other, then that's all they want. That's all we care about. So then this means that the limit as x approaches negative 2 from the left of, you will tell me what, equals the limit as x approaches negative 2 from the right, and you'll tell me what. So when we determine the limit from the left, which branch are we going to use? We can only use one or the other.
X squared minus 8.
Very good, of course. X squared minus 8, right here. This is it. Who was that?
That's me.
Lake. Okay. Good. So now from negative 2 to from the right. Amin, will you tell us negative 2 from the right?
Negative x squared plus c.
Very good, of course. So both have to exist and be equal to each other. Okay. We haven't discussed this. I was going to do something like this in 1.2, but here is a theorem. When we determine the, before you answer this question, when we determine the limit as x approaches a, from the left, from the right, from either side, it doesn't matter, from a polynomial, and I'm going to call this polynomial p of x. Every time I determine the limit of a polynomial, p of x, f of x, a polynomial, when x approaches a, all I have to do is plug it in. And I know that this is a contradiction. How come that this is a contradiction? It's because I told you several times that when we say x approaches a, we literally mean approaches. It will never equal a. But here I am asking you to plug it in. So this is a contradiction. Not really. It's because for a polynomial, when we determine the limit from either side or one side or the other, it doesn't matter, the result will end up being this. But I emphasize this concept that when we say x approaches a, we really mean it. Approaches does not equal a. So since this is a polynomial and this is a polynomial, we can determine the limit from the left and the limit from the right. So what is the limit from the left? What does it equal to? All I have to do is just plug it in. I just want to push my device a little bit so I can have more room for my pages. Okay, so what is the limit of x squared minus 8? It's a polynomial when x approaches negative 2 from the left. What will it equal to?
Negative 4.
So I have negative 2 squared minus 8, which will be indeed all this limit when we plug it in Negative 2 squared is 4. 4 minus 8 is negative 4. Good. Who said that?
Amanda.
Thank you. The same thing for the other one. Why? Because it's a polynomial. We have other theorems for other functions too, but for now, since we are looking at polynomials, let's concentrate on this.
So you want this one to also equal negative 4, right?
No, you just tell me what it is. Yes, that will be the next step. But right now, let's focus on what it equals to.
Oh, sorry.
No, that's okay.
4 plus c.
Careful. So let's discuss this. This is very important.
Oh, I'm sorry. Negative 4 plus c.
Yes, yes. Negative 4 plus c. So I want to emphasize the difference between this and this. Are they equal? A lot of my students say that in my class they learn calculus, pre-calculus, and algebra as well. And it's true. So negative 2 squared, I have to square negative 2, and that's why I get, Gabby?
Negative 4.
When I square negative 2, I get?
Negative 4. I mean, 4.
Excellent. And when I square 2 and then multiply by negative 1, what do I get?
Negative 4.
Negative 4. So these two are not equal to each other. So please remember that. Here you're not squaring negative 2. Here you are squaring negative 2. Or we are squaring negative 2. Here we're not. By the order of operations, I have to square 2. And then multiply by negative 1 in front. So understand the difference between the two. So coming back to our relationship, indeed, as Amanda said, negative 4 has to equal negative 4 plus c. So I will write the equation. Negative 4 equals negative 4 plus c, and from here I determine c. And I put it back in the function. How much is c from here? Alex? Alex, are you with us? Alex, 1, 2, 3.
Yeah, I'm sorry.
No worries.
What was the question again? So 0.
Thank you. So now I have to write the whole function again. And here it is. X squared minus 8 for x less than negative 2. And negative x squared for x greater than negative 2. Definitely the limit as x approaches negative 2 from f of x. Can anyone tell us how much it equals to?
Negative 4.
Thank you very much. Great job. So we made it the limit to exist by determining c. Is this better? It's a very good problem. Thank you for bringing that to class. I forgot, who was that?
Rita.
Rita, thank you. Is this clear
I just have a
now?
question.
Yes.
Could you go back to the other paper really quick?
Just for you. If anybody else, I'm kidding, of course.
So if the limit of x approaching negative 2 from the left is always going to be equal to x approaching negative 2 from the right, couldn't you just find one and have that be equal to both? Or do you have to solve for both?
And here you have a parameter. Here you don't have a parameter.
Yeah, but they're equal to each other, right?
But that's why we had to determine them first to set them equal to each other. I took the negative 4 from here, and I took the negative 4 plus c from here. I set them this equal to this here on this page because I ran out of room. I always run out of room. And then I determined that c must be 0. Negative 4 plus what is negative 4? C must be 0.
Okay, thank you.
Thank you. And then we put it back in as 0, and that's it. Better? So you understand that if you don't ask questions, you're not helping me. So thank you for asking questions. And you're not helping yourself and the other colleagues. Great job. Anything else here? Do we have anything else? Okay, so let's go back and then to and continue with 1.2. 1.2, in 1.1, we looked at, basically in 1.1, we looked at limits. So we learned the limit operator, okay, as x approaches a from f of x. We know that the limit exists only if I can give you a number, -4, then the limit exists. We know that we have left-hand limit and right-hand limits, and we looked at graphs. So from graphs, we were able to determine the limit from the left and right, if it has from either side, etc., etc. Okay. Now, in the next section, we're going to look at algebraic limits. We're not going to need to look at the graph now. We have other ways. We don't need to always graph in order to determine the limit. And we also will going to talk about continuity. When is a function continuous? In addition to that, we're going to talk about the limit laws. Limit laws. And I am going to start with this. I'm going to start with the limit laws. And there are several. So here is one. The limit of a function f of x plus a function g of x as x approaches a. So assumptions. Without these assumptions, I cannot calculate anything. And the assumptions are that the limit from f of x as x approaches a from either side is a number. We're going to denote it by L. The other assumption is that the limit of g of x as x approaches a also exists. Let's call it m. It doesn't matter. These are arbitrary. You can put a and b. Your book and other books that I'm teaching from, they use L and M. It doesn't matter. So these are our assumptions. What do they say? They say that the limit from f of x as x approaches a exists, and it's a number L, and the same thing for g. If that is the case, I can have here positive or negative. It doesn't matter. Then I can write the limit of f of x as x approaches a, either positive if it's positive or negative if it's negative. I like to combine these two laws together, of the limit of g of x as x approaches a. And of course the answer will be, if this is L and this is m, if this is plus, I have plus. If this is minus, I have minus. So what does this say? It says that the limit of a sum is the sum of the limits, if they exist. If one is 4 and the other one is infinity, I cannot use the law. So the limit of a sum is sum of the limits. The limit of a difference of two functions is the difference of the limits of those functions. So that's property number 1.
Wait, can you pause for a second?
Sure.
Can you repeat that like in words, what you said? The limit of a sum.
The limit of the sum is the sum of the limits.
Sum of the limits. Okay. So does that mean? Okay, I'll wait. I'll wait for an example and then see if I
yeah, it's a very good question. Let's look at an example right now. Perfect. So here's an example. So if I have limit of x squared plus 2x as x approaches 4, because the limit of x squared exists and the limit of 2x exists when x approaches 4, I can write limit of x squared as x approaches 4 plus limit of 2x as x approaches 4. Can anyone give us the first limit? It's a polynomial, we know that. Sorry?
16.
Very good. Plus? Good. So this is 24. Now here's a counterexample. So for example, if I have limit as x approaches 0 from the right of 1 over x plus 2x, I cannot write limit of 1 over x plus limit of 2x as x approaches 0 from the right. Question is why? Can anyone explain why I cannot write this?
Because it's only from the right?
No, it doesn't matter. So when we write this, obviously it has to be from the left and from the right, or one or the other, it doesn't matter. What is this limit equal to?
0.
Good. Well, what is this limit equal to? And this is a crucial element because we did talk about this function. No. We talked about this function 1 over x. You have to have these functions in the back of your mind forever because it will always make our life much easier. So what does this, so this is the function 1 over x, and what is this limit as x approaches 0 from the right?
It's undefined.
Careful, 0 from the right.
0 from the right.
Follow the function with your finger or pen or marker.
Infinity.
Absolutely, indeed. Thank you. Who said that?
Jackson.
Very good. As x approaches 0 from the right, I follow the function. That's where it's going. So this is infinity. So I cannot use the limit law. The assumptions are not fulfilled. One of them is an infinite limit. It does not exist. We cannot write dne. We have to write infinity. But it's dne. But I cannot write dne for this situation from one side. In this case, it has to be infinity. So the limit laws cannot be applied.
The limit altogether, though, can't exist, correct?
The limit altogether does not exist as infinity. But you cannot use the limit laws.
Okay.
Because the assumption is not fulfilled. These two have to be two numbers. But this is not a number. So the limit as a result is infinity. Because infinity plus 0 is infinity. But you cannot write this. The limit of the sum does not equal the sum of the limits. So you cannot use the limit law. Very good. Moving on. So let me